Alright guys, so I said that I was going to split this lesson interpreting expressions into two separate videos. So the first video I did was about evaluating expressions by substituting values. But this one is going to be devoted to multiplying fractions and cross-reducing and converting units using this method that we call unit analysis. Alright, so the first example that I've got here for multiplying fractions and unit analysis is this one, example 6. It's really a simple expression, a multiplication expression, but it's multiplication of fractions. And whereas maybe your prior teachers taught you to multiply across tops times tops and bottoms times bottoms, I'm not saying that that's an incorrect method. I just want you guys to start learning how to reduce first, then multiply. So this is what I mean. You look across, you look at your problem, and you look crosswise. In other words, you look in a crisscross or diagonal fashion to see if any of those numbers have a factor that's in common. So when I look at my 15 and my 9, I say to myself, they're both divisible by 3, so I'm going to divide 9 by 3 and get a 3. I'm going to divide 15 by 3 and get a 5. So I'm cross-reducing. I'm reducing and crossing out my factors as I go. Looking the other direction, I see the 12. Let me change colors so you can see it better. I look at the 12 and I look at the 24 and I say, oh, they're both divisible by 2. But actually they're both divisible by 4. They're both divisible by 12. So I'm going to divide 12 by 12 and get a 1. Divide 24 by 12 and get a 2. So now the numbers on top and bottom are much more manageable. They're smaller. Now is when I'm going to say tops times tops and bottoms times bottoms. So I'm looking at 1 times 3, which is a 3, 5 times 2, which is 10. So the answer to that problem is 3/10. Now don't be alarmed when you see variables, because when you multiply with variables, you don't have to worry about like terms. But what you do want to do is kind of treat them as factors and reduce or cancel accordingly. So when I look at this problem that has fractions with variables in it, not only will I look diagonally and try to find numbers that reduce. Let me fix this really quick. I'm also going to look at the variables and see if I can get those to reduce. So I'm looking diagonally. 32, 55, I don't see anything in common right now. I don't even see a B that's in common. So now I'm going to look the other direction. 14 and 35. I believe 7 goes into both, so 14 divided by 7 is 2. 35 divided by 7 is 5. Well, although I can't cancel anything more numerically across this way, I can reduce the A's. I'm going to say A divided by A is 1 and A divided by A is 1. So the A's cancel out. Now, a couple minutes ago, I want you to see this, I decided I could not reduce the 32 and the 55 because they had nothing in common. But don't dismiss the idea of any top with any bottom. So I can reduce the 55 now with the 5. So I'm going to say both of them are divisible by 5. I'm going to cross out this 5 and say in my head 5 divided by 5 is 1. 55 divided by 5 is 11. And at this point I think I've reduced as far as I can reduce. So now it's time for tops times tops and bottoms times bottoms. 2 times 1 times 11 is 2 times 1 times 11, 22. 32 times B times 1 times 1. So 32 times B times 1 is 32B. Now where is, oh look, I didn't notice it at first. Remember when I was doing the tops and bottoms with the 55 and the 5? Look how I didn't notice the 32 and the 2. Oh well, no worries. You can reduce at the beginning or the end of a problem. But you see how it's jumping out at me right now? I got to address it. Let's pick a different color. I'm looking at my 22 and my 32 and I'm thinking both of them are divisible by 2. So 22 divided by 2 is 11. 32 divided by 2 is 16. So really the final reduced version or the simplified version is 11/16 B. Let me redo that. I can say 11 over 16b, or if I want, I can write, no I can't, leave it alone, 11 over 16b. Alright, so here we have another one. This multiplication problem, though, has 3 fractions that you're multiplying. It's not a big deal. It looks a little intimidating, but what I want you to keep in mind is really just one thing. You can cross-reduce any top with any bottom. So whereas you would look at this problem and you'd probably say to yourself, I can only reduce these two, 15 and 27, because they have a 3 in common, I don't want you to dismiss the fact that technically you could reduce the 15 with the 30 clear across the other side. Okay? As long as it is a top with a bottom. Now what you couldn't do, just want to make sure you understand this, what you couldn't do is try to reduce, oops, didn't want to do that, is try to reduce this 15 with this 36 because they are both bottoms. Okay? So what we're going to do is we're going to reduce the entire fraction, any top with any bottom, and then we're done, then we'll multiply tops times tops and bottoms times bottoms. All right, here we go. And by the way, there's no rhyme or reason, just go to what your eyes see first. And I'm going to say, at first I was going to do the 15 and the 27, but now I'm all about reducing the 15 and the 30. It just looks right. So I'm going to say 15 is divisible by 15. 5 divided by 5, 15 divided by 5 is 1. 30 divided by 15, did I say it right? Let me try it again. 15 divided by 15 is 1. 30 divided by 15 is 2. All right, now I'm going to take care of all of my numbers first. So the next thing that jumps out at me is the 8 and the 2. Oh, you know what? Shoot, wait a minute. How about the 2? Let's do this, different color. How about this 2 reducing with this 2? 2 into itself once, 2 into itself once. Doesn't that work? Sure it works. Okay, let's try another one. Just whatever jumps out at you. Now I'm looking at the 8 and the 36, and I'm thinking they're both even, so I can divide by 2. But I'm pretty sure 36 is divisible by 4. So I'm going to divide 8 by 4 and get a 2. Then I'm going to divide 36 by 4 and get a 9. And while I thought I was done, nope, I can reduce the 9 and the 27. Okay, so keep in mind, there's no rhyme or reason. Just go with where your eyes are drawn first. So 9 divided by 9 is 1. 27 divided by 9 is 3. Okay, I think I've reduced all of my numbers, all of my coefficients, as much as they can be reduced. Now it's time to tackle the variables. So I can reduce any variable with itself. You see this x on top? I can reduce it with that x on bottom. I can reduce this y on the bottom with that y on the top. By the way, when I reduce, I'm saying y divided by y is 1. Y divided by y is 1. And then I see, let's see, I've got x squared left over here, and I've got an x down here. Hopefully you remember about reducing variables or exponents. The shortcut, remember, is to take the exponent and subtract top exponent minus bottom exponent. Or the way I taught my students was, let's just reduce. If this is x times x, and this is just 1x, why can't I reduce that x with this x and have just a x left over, just one x left over? Okay, so all the x's have been reduced. My problem looks like a horrible mess, but it's done. I have reduced by multiplication. Looks like this top times that top times this times 1. 2 times 3 times x times 1 is 6x. And then on the bottom I have 1 times 1 times 1 times, nice, 1. Everything's over 1. So 6x over 1 would simplify to just 6x. Isn't that amazing that original problem that started so complicated looking reduces to something so simple? 6x. All right, the last one I wanted to tackle on the multiplying fractions section is when you multiply a fraction over a binomial, or when you use the distributive property. The distributive property acts the same way even if the number on the outside is a fraction. You just remember you're multiplying that fraction times everything on the inside. And the way I've got it written, I've got a fraction being multiplied by two whole numbers. And so what you do when you multiply a fraction times a whole number is you put a 1 underneath each one of those whole numbers. And so you're thinking 2/3 times 6n minus 2/3 times 21, or 21 over 1, 6n over 1. And so when you start reducing like you can do, the 3 reduces with the 6, and you get 2 times 2n, 2 times 2, isn't that 4? 4n minus, and then on this side, I say side, I shouldn't say alright, I shouldn't say side, because I like to reserve the word side for when I'm working on left and right side of an equation. This is not an equation. So on this part, on the right hand part of my problem, I'm going to reduce this 3 with a 21, and I'm going to say 2 times 7 is 14. So the answer to this problem in terms of multiplying or simplifying by using the distributive property is 4n minus 14. Okay, I think you've got enough information to be able to tackle those fraction problems. Good luck.